Okay, we'll take a look. What do we call this type of equation? It is ugly. I'll take that. The variable's in the exponent, so we call it an exponential equation. Now, the easiest way to solve an exponential equation, if you can do it this way, is to write both sides using the same base. Now, on the first example, on example A, can you write both sides using the same base? Absolutely, and it's not too hard to do, is it? So we're just going to write 2 to the x squared, and we're going to write this side as 2 to the third. If the bases are the same, then the exponents have to be the same, so that means that x squared has to be the same as 3. And now I can just use inverses. I need to undo squaring. How do I undo squaring? Take a square root. So I'm going to take the square root of this side and the square root of that side. So that's going to give me x equals plus or minus radical 3. So I get two answers for that one. Again, with most equations, you're going to want to look at it and say, does my answer make sense? Is it okay if I plug it back in? Do I have any domain issues I need to be careful with? Remember, if you've got division, you got to be a little bit careful. Because not any number can be plugged into a division problem. If you've got roots, even roots, you can't take even roots of negatives. Okay, and if you've got logarithms, you've got to be careful because you can't take the log of a negative or a 0. Now this is an exponential. Okay, is that on that list of problems? No. No. So this is okay. If I were to plug in square root of 3 squared, I get 3. 2 cubed is 8. If I put in a negative radical 3, that's going to square. I'm going to have two negatives. That's going to be a positive 3. 2 to the positive 3 is going to be 8. So those are the two answers. Okay? This one is a little more difficult. It's still an exponential equation. The exponent is a little bit easier. Okay? But the problem with this one is I can't write both sides using the same base. We actually did both of these problems before. Does anybody remember how we did this? There are actually two ways to do this. One way you can do this is you can get rid of the exponential base 2 by undoing that, by taking the log base 2 of both sides. So if I do log base 2 of this side and log base 2 of this side, what does this function do to this function? It undoes it. It gets the exponent down where we can work with it. So x is equal to log base 2 of 17. Now that's the exact answer. If you wanted a decimal for that, you'd have to plug that into your calculator using the change of base formula. Okay? The other way to do that one is one of those things when we introduced logarithms, I said, hey, please try and remember this. Maybe you forgot it over the break. If you can't figure something out in exponential form, write it in logarithmic form. And if you can't figure it out in logarithmic form, write it in exponential form. They both are very valuable, and sometimes it's easier to see what the answer is. So this is the base, this is the exponent, and that's the number that it equals. So if we wrote this in logarithmic form, this would be log base 2 of 17. Remember, the answer to a logarithm is an exponent, so there's where it is right there. We get the same answer, it's just done a different way. We just think of it differently. Okay? So that is the answer. Perfectly good answer. It's ugly. If you type it into your calculator, it would be a really awful decimal. It'd be 4 point something. It'd go on forever. It wouldn't repeat. So it would be an irrational number. Okay, any questions there? Okay, does anybody remember how to solve this? This is called a proportion. When you have two fractions that are equal to each other. Yep. You can do that. We could multiply everything by something that will cancel off the denominators, or you can do what are called cross products. You can multiply like this. Okay, either way, you're going to end up with the same result. Now, before we finish solving this, I'd like you to look at that. Let's say I got an answer of 5. Would 5 be okay to plug in? Yeah. What if I got an answer of -3? I get all done with all my algebra work. I get an answer of -3. I look at that and I say, wait a minute, Tatum, what do I say? it would make this one equal to 0. Okay? So we'd have to throw that answer out. So this has domain issues. The two numbers that would not work here, no way, no how, would be -6 and -3. So as we're solving this, let's be a little bit careful. So I'm going to do this. I'm going to do cross products. I'm going to multiply these together. So this is going to be x plus 3 times x minus 1. And this is going to be x plus 6 times x minus 2. Now this looks really awful. It's going to turn out not to be too terribly bad, because this is going to be x squared plus 2x minus 3. We okay? This side's going to be x squared plus 4x minus 12. Now, even though that looks ugly right now, what's nice about this? You can move everything over to one side, and the worst part of this are the x squareds. That makes it harder to solve, but there's one on each side, so what happens to it? It goes away. So I'm going to do this. I'm going to cancel those right here, and I'm going to move everything over on this side. So I'm going to subtract 2x, and I'm going to add 3. Whoops. Let's do this, since we can just move these around. Let's move the 12, so let's add 12. So this is going to be a 9 over here, and this is going to be a, what do we got here, 2x. So this means the answer is 9/2. Is that one of the two numbers that would not work? Nope. So do we get to keep that answer? We do. Okay, that is the solution. Okay? Any questions? Okay. And then the last part of the starter question is, logs and exponentials of the same base are inverses. The word is inverse. Okay? They are inverses of each other. Now, I'm going to ask a question. I don't want anyone to answer this out loud. I want you to think for just a second. What do inverses do to each other? How are they related? Okay, thank you for not answering. Okay. I will buy that answer. Okay, Charles, will you say that again? That is the right answer, by the way. They undo each other. Okay? Don't say they're reciprocals. Don't say they're opposites. Say they undo each other. That is what an inverse does. Whatever one function does, the other one undoes it. Okay? And it doesn't matter the order in which you apply those. Okay? Inverses undo each other. Okay? So what we're going to do is we're going to solve these types of equations using inverses. Okay? Now it says write both sides using the same base and use an inverse function. So we've solved these right here by using that idea. Well, guys, if we make the bases the same, the exponents have to be the same. So on this problem right here, we do 2 to the x and we do 2 to the 4th. And what that means is if the bases are the same, then the numerators have to be the same. So that's got to mean x is equal to 4. Okay? But what is the inverse of that function right there? What is the inverse of exponential base 2? Log base 2. So just like if we had the square root of x is equal to 16, everyone would know, hey, I just need to square to undo that. How do I undo exponential base 2? Log base 2. Okay? So I'm going to take the log base 2 of both sides. So if I do log base 2 of 2 to the x, and I do log base 2 of 16, what do these two functions do to each other? They undo each other, so that's an x. What is log base 2 of 16? 2 to what power equals 16? 4. Okay? Now, this one is easier. There's no doubt about it. But this one emphasizes a really important idea. Pretty much all of math is about figuring out how to do something mathematically and then knowing how to undo it. In every single math class you take, you're going to find an operation. You're going to do something and then you're going to undo it. Okay? The very first thing you learned how to do in math was add. What did you learn next? You learned how to subtract. Those are inverses. Okay? And that happens all the way up. If any of you in here end up taking calculus, you're going to learn how to find derivatives, and then you're going to learn how to find antiderivatives. They are opposites of each other. Okay? They undo each other. All right? So if we're solving this problem right here, which we already looked at up above, I can solve this one by writing, log base 2 of 2 to the x equals log base 2 of 17. These undo each other, so I get x equals log base 2 of 17. Now, the nice thing about this one is that you can't solve this by writing both sides using the same base, okay? You could do what we did before. You could go from exponential form to logarithmic form. But the nice thing about knowing how these functions relate to each other is you know what will undo it, okay? So let's take a look at this next problem down here. On example 2, it says solve by writing both sides using a log of the same base and by using inverse functions, okay? So let's look at this one right here. This is log base 3 of 4 equals log base 3 of 5x. It's already written with the same base, right? So the only way these two things could be equal is if 4 is exactly the same as 5x. Does that logically make sense? No? Okay, how about I do this? You can't see through the purple, right? Not really, anyway. If these two sides are exactly the same, and that's a log base 3 of something, and that's a log base 3 of something else, the only way those two things could be equal is if what's underneath this purple block is the same as what's underneath that purple block. Does that make sense? Okay? A lot in the same way that we did this. If I have 3 to the 2x equals 3 to the 9th, the only way these two things could be the same is if this equals this. Does that make sense? Okay, we buy that argument? Okay. So, if that's the case, let me go back here and erase. The only way these could be equal is if 4 is equal to 5x, which means x is going to be 4/5. And that would be the answer. Now, you do have to check and make sure. Does this actually work? Logarithms are one of those functions that have issues. So if I take this and I plug it in here, I'd have log base 3 of 4 equals log base 3 of 5 times 4/5. What happens with 5 times 4/5? Yeah, they cancel off, so this is a log base 3 of 4. This just says log base 3 of 4 equals log base 3 of 4. Isn't that true? Okay. All right, any questions? Okay, so here's the other way to do it. What undoes log base 3? Exponential base 3. So what was that word again? Okay, it is an inverse. Okay, what we're doing here is we're not taking the log of both sides. We're not taking the square root of both sides. We're not squaring both sides or dividing both sides by 2. We are exponentiating both sides. So that's the word of the day. I think I mentioned that the other day. Okay, so the word of the day is exponentiate. Exponentiate. Exponentiating both sides will undo a logarithm. So if I do 3 to this side and 3 to this side, what does exponential base 3 do to log base 3? Undoes it. What does exponential base 3 do to log base 3? Undoes it. We get this here. Same equation, solve it, you get x equals 4/5. Okay? Any questions? Okay, let's do this one right here. I need to get this x by itself. I need to get rid of a log base 8. Much the same as if I had this. Let's say I had the square root of x equals 2. How would I undo that? Square both sides, right? Well, I need to undo a log base 8. What will undo a log base 8? Exponential base 8. So I'm going to do 8 to this side and 8 to that side. I'm going to exponentiate both sides. So what does exponential base 8 do to log base 8? Undoes. Gives me the x all by itself. And over here I get 8 to the second power. 8 to the second power is 64. Now, before we just blindly go on, will that work? Can I plug that in? Is log base 8 of 64 an okay number to compute? It is, because I'm taking the log of a positive. Remember, the only things you can't take the log of are 0 or a negative. Any questions there? Okay. Does anybody know a different way to solve this? Yeah, write it in exponential form. If you stared at this for a while and couldn't figure it out, just say, well, it's in logarithmic form right now. Let's write it in exponential form. There's the base, there's the exponent, there's the number that it equals. So this would be 8, there's the base. The answer to a logarithm is an exponent, and it equals this number right here. So you get 64 equals x. Either way is fine. I like the whole exponentiating thing because it reinforces that idea that we're learning how to do something and we're learning how to undo it. Okay, are there any questions? Sure? What's the word of the day? Exponentiate. Okay, it means we take both sides and raise it up in the exponent. Okay, so now we're going to solve this using properties of logs, exponentials, and inverse functions. What function is that? Okay, that is exponential base 10. How are we going to undo it? Log base 10. Okay, so we're going to take the log of both sides. What do these do to each other? Undo, so we get x equals the log of 108. That's it. End of story. Done. They get a little more difficult here. So please make sure you're paying attention. If it's been easy until now, make sure you catch this, because we kind of have to put all the rules that we've been learning together here. Log base 4 of 3x. Log base 4 of 30 minus log base 4 of 2. Ideas here? What's that? Put them together. Okay, use those properties of logs that allowed us to take logs of the same base. If we were adding or subtracting, we could change it into multiplication or division. Okay, this has a negative in front of it, so this is going to go on the bottom. So this is going to be log base 4 of 30 over 2. So this is log base 4 of 3x, and this is log base 4 of 15. Okay, now, you can solve this one by logic. These both have the same base. The only way the two of these things are going to be equal is if this equals this. So we could just run over here and we could say, look, this means 3x has to equal 15, which means x has to equal 5, and we're done, right? Are we done? Okay, we are done. This is the right answer, but you should check to make sure. Is it okay to plug that in there? Does it make sure we're taking the log of a positive? If you plug that in there, that's log base 4 of 3 times 5. That's log base 4 of 15, so that's okay. Make sense? Okay. You can do this, or what would be really nice is, how do you undo log base 4? Exponential base 4. Exponentiate both sides. This side is a 3x because these two undo each other. Those two undo each other. And we end up with 3x equals 15. I don't really care how you do it, okay? But it would be good if you kept that in mind sometimes, that you can exponentiate to undo a logarithm. Okay? It does come in handy. Any questions? Sure? Samantha, how are we doing there? Excellent. Okay. All right, let's take a look at this one. Can I slide this down? We're good? Okay. All right, let's take a look at this one. Log base 4 of x plus log base 4 of x minus 3 equals 1. Caitlin, what are we going to do here? Put them together. Okay, use those properties. Because this is addition, when we write it as one single logarithm, what are we going to do? We're going to multiply them together. Now, there are two things that you could do at this point. You could exponentiate both sides, or you could kind of translate this, change this from logarithmic form to exponential form. I'm going to exponentiate just because I like saying that. This side is x, x minus 3. What's this side?
4.
It's a 4. Okay? And then you've got to know what to do to solve that. Again, we're learning about logarithms and exponentials. But even though that's what we're learning, we still can't forget all the stuff we learned in Math 1010, how to solve quadratic equations and different things like that. How would we solve this? Okay. First thing we'd probably want to do is we'd want to distribute through. collect everything on the same side and set it equal to 0. Again, we take advantage of the 0 property of multiplication. This is a quadratic. Your first option for solving a quadratic is, that's a good one. It will always work, but if you can factor, it would be easier to factor. Okay? So let's see if we can factor this. Let's see, this would be two numbers that multiply to be -4 that combine to be -3. So if I use a -4 and a +1, that would do it, wouldn't it? So what are the two solutions I get from here? I get x equals 4 and I get x equals -1. Now, I've got two potential answers here. I've got the 4 and I've got the -1. Do they both work? I see some of this. I see some shaking heads yes, and I see some shaking heads no. The no's are correct. Okay? Tatum, can you tell us why one of these answers doesn't work? You can't do the log of a negative. So the 4 works just fine. If I put a 4 here, that's log base 4 of 4. I can find that. If I put a 4 here, watch please. This is important. If I put a 4 here, it's not that there's a -3 in there with it. Okay, it's that when I do 4 minus 3, that's a 1, and I can take the log base 4 of 1. It's a positive number. Okay? Now again, it's not that this is negative. Don't just say, oh, there's a negative answer and throw that out. Actually plug it in and see what you've got here. Here we've got log base 4 of -1. We know that's not okay from the get-go. And also, if you tried it here, this would be -1 minus 3. That would be -4. You can't take log of base 4 of -4. Okay, so we're going to throw this one out. Remember, that's called an extraneous solution. Okay, you don't have to worry about that, but that's just a good trivia thing to keep in mind. Okay, so the only answer from this one is that guy right there, just 4. Okay. You can be nearly guaranteed that on a test that I give, and especially on a final in 1050, if there was a logarithmic equation like this, there probably would be two answers, and they would want you to be able to check for both of them. Okay? And the odds are one or both of them would not work. Okay? Because they want to see if you're paying attention to that. Okay, are there any questions? We're good? Okay, let's take a look at this one right here. This one is fundamentally different. This is unlike any problem we've done before. But if you know what you're doing, if you've paid attention to how we've solved exponential equations and logarithmic equations, the relationship between logs and exponentials, you should be able to do this. That's an exponential equation. The problem here is the variable is up in the exponent. It's somewhere where we can't work with it. We've got to get it down where we can work with it. What got it down so we could work with it here? A log. So the cool thing about logarithms, it doesn't matter what the base is. Notice there's no way we're going to write both sides with the same base. We're not going to write a 3 with a base of 4, and we're not going to write 4 with a base of 3. So we're pretty well stuck in doing this problem unless we realize, hey, you know what? Logs have this really nice property. They have this power property where we can take the exponent and we can move it down. So here's what we're going to do. We're going to take this one, and I'm going to take the ln of both sides. Now, as long as I'm doing the same thing to both sides, isn't that algebraically legal? Yep. So this is going to be the ln of 3 to the 1 minus 2y. And this side is going to be the ln of 4 to the y. Now, for the time being, that looks worse. It looks like I made things more complicated. But now that I've got a logarithm on both sides, I'm taking the log of this side and the log of this side, the natural log. Okay? What can I do with the exponents? I can move them out front as a factor. So I can take this and I can move it out front. Now, you'll notice that the parentheses were not in the problem to begin with, but you do need them when you bring it down. So this is going to be 1 minus 2y in parentheses times the ln of 3, and this is going to be y times the ln of 4. Okay, now, everybody watch, please. Okay, this is no more difficult than doing this problem right here. If I had 1 minus 2x times 7 equals x times 14 or something like that. Everybody could solve that, couldn't they? This is the same thing. That number right there is ln3. It's not as nice as 7, but it's still just a plain old number. That number right there is ln4. It's not as nice as the number 14, but it's still just a plain old number. So if I were going to solve this problem right here, what would you do first? Distribute. Okay? And that's what we're going to do here. So we're going to distribute. So this is going to give me 1 times the ln of 3. So that's going to be ln3. This is going to be minus 2y times the ln of 3. And over here I have y times the ln of 4. That would be the equivalent of getting this problem to this stage. 7 minus 14. Oops, so I picked a bad number here. I'm going to change this to 15, okay? Now I'm going to change it to 23, okay? And this is going to be 23x. That would be the equivalent. What would I do if I were doing this problem? Move the 14x over, right? So what am I going to move over here? Yep. So I'm going to add 2y ln 3, add 2y ln 3. Okay, now, those are gone. This gives me ln 3 equals, and I'm going to write this as y ln 4 plus 2y ln 3. Now, the goal of solving an equation is to get the variable on one side by itself so you can just read off the answer, like x equals 4 or x equals 3/5 or whatever it happens to be. I've got the y's on one side, but I've got 2 of them. I don't want 2 of them. I only want 1 of them. Does anybody remember what to do with this? Okay, we can add them together, but they're not exactly like terms. Shane? Now if we exponentiate, that would actually make quite a mess. Yeah. Yeah. Let's factor out a y. Okay, please listen. This is going to come up again. You're going to stare at a couple homework problems or maybe, unfortunately, a test question. And you're going to think, my gosh, how do I solve this? How do I get y by itself? Okay, if you want to make it look like there's only one y on that side, take the y out. If you take the y out, you're left with ln 4, which is just a number. And you're left with 2 ln 3, which is just a number. And on the other side is ln 3, which is just a number. Now, how do you get the x by itself? Sorry, y by itself. Divide. Divide by ln 4 plus 2 ln 3. Divide by ln 4 plus 2 ln 3. That entire factor cancels with that entire factor, and here's what we've got. Okay, now I'm going to change colors just for emphasis. The answer is y equals the ln of 3 over ln 4 plus 2 ln 3. Any questions? Okay, can I cancel the ln 3 on the top with the ln 3 on the bottom? No. Somebody tell me why not. It's not a factor. It's part of a term. Okay, it's part of a term. You can only cancel factors. You can't cancel terms. Okay. Is this the only way to write this problem? Nope. And that's the interesting thing once you get to logarithms. If you look in the back of the book, it may have this as an answer, or it may have something else. So let's think about this. We are interested in writing things as simply as possible. There's not a whole lot I can do with the top, but I could do this. I don't know what ln 4 is, but instead of doing this, I could write ln of 3 squared, which is 9. I could do that. That might be okay. That actually looks a little better, doesn't it? Caitlin, what can I do with these? Put them together. Logarithms change addition to multiplication. So this is going to be y equals the ln of 3 over ln of 4 times 9 is 36. Now, can I cancel the 3 with the 36? No, you can't. Okay? That's not really a 3 and that's not really a 36. It's the ln of 3 and the ln of 36. So this is probably about as simple as it gets. Okay? You could get really funky and do this. Log base 36 of 3. Okay, but don't bother. Okay, don't bother. All right, any questions? We were probably yapping on that one problem for 7 or 8 minutes. Okay. Exponential equations and logarithmic equations can be pretty darn tricky. Okay. If there's one of the topics that people struggle with in 1050 is solving equations like this. They get lost in all the different ways that you can write the answers. They get lost in not putting parentheses on here so they don't distribute through correctly. They get lost in trying to factor those things out. So this is a very, very good problem to practice. Okay, you'll see some on your homework and you're going to see it again when you take 1050. Yeah.
I don't understand where you got both of those ln3s on the third line. ln3 minus 2y ln3.
Right here?
Yeah.
We distributed through.
Oh, okay.
Okay. Anything else? Okay. Let's see. Let's take a look at this problem right here. And then we'll do 5 or 6 problems tomorrow. You'll have some time to work in class, get the assignment done. This would take me quite a while to figure out. This is not something most people come up with on their own. Could you write this one this way? Is that the same thing? Power to a power, don't you multiply them? So I could write it like this, 2 squared to the x. Okay? Or I could put the x on the inside and the 2 on the outside. It doesn't make any difference. It's still going to be 2 to the 2x, right? Okay. Does anybody recognize that? It has 3 terms. We can do something called a U substitution. U substitutions or a change of variable are used to make things look more familiar. So what if I said, hey, you know what? I've got this thing squared plus this thing minus some other number. It's a trinomial. What if I said u equals 2 to the x? So wherever there's a 2 to the x, I'm going to put a u. So this becomes u squared, whoops, plus u minus 12. Now, ignore everything from here up. Does that look familiar? Yeah, that's not too bad. We can solve that. We're looking for 2 numbers that multiply to be negative 12 that combine to be positive 1. That's going to be positive 4 and negative 3. Am I right? That means u equals negative 4 and u equals 3. Now, we'd be done with the problem if the problem were about u's. What's the problem about? It's about x's, right? So we now reverse the substitution. We change back to the original variable. So this is going to be 2 to the x equals negative 4 and 2 to the x equals 3. Now, can I ever have a positive number raised to a positive power, or any power, and get a negative? Nope. No solution. Okay? Nothing from there. And the problem with this is the variable's up in the exponent. If the variable is up in the exponent, how can I get it down? Take a log. What log do you want to take? Log base 2 would definitely undo that, right? I'm going to do this. I'm going to do ln 2 to the x equals ln 3. That's x ln 2 equals ln 3. And then to get x by itself, ln 3 over ln 2. Now, you suggested that I do log base 2. That would undo this. That would give me x equals log base 2 of 3. And that would be the answer. Why is this one right here perhaps a little bit better than that one right there? Why is this one better? Josh? You can plug that into your calculator and get a decimal approximation. Okay? All right. That's enough. You can get started on the assignment. Please do get going on it. Do what you can. I'm going to finish up the lecture tomorrow, and you'll have some time to work in class. Yeah.
Why was that no solution?
Because you can't, an exponential is always positive, and we're saying a positive equals a negative. A positive will never equal a negative.